welcome to what I call statistics or lying with math. We're going to look at a data set today to determine whether they are using statistics to lie with math or if they're staying true to the data set. So let's look at this data set. It's a set of test scores from a math class. If the class average is 85% or more, they get a pizza party. So there's some pressure on. However, as we look through this data set, there is something that looks suspicious. Looking at Holly's score right here, that is significantly, apparently, different than all of the other scores. And when in fact, if you were to calculate the class average with Holly's score, you get an 82.8%. Without Holly's score, an 86.1%. Wouldn't it be fabulous if we could drop Holly's score and have a pizza party? And Patrick would suggest that we should. We should be able to take that outlier and put it somewhere else. However, is that lying with math? Your gut says we can do it, but can we prove it? Well, let's look at the data set. I've redone it linearly so that we can look at some values easier. We're going to use something called the lower fence to be able to determine if that score of Holly's, that 30, is indeed an outlier that can be defensively dropped. If we were to calculate the median of this data set, we would come up with the value of 87. Now, according to the formula that we have right here, the lower fence is equal to quartile 1 minus 1.5 times the quantity of the interquartile range. So we need to calculate where the quartile range is and apply that. So to find the quartile 1, we need to find the median of the lower half of the data set. That value is going to be somewhere in between 75 and 77. And in fact, it's going to be exactly halfway in between. When we calculate the average of 75 plus 77 and divide that by 2, we come up with a value of 76. Quartile 1 is 76. So let's rewrite this formula. Quartile 1 is 76. 1.5 is just 1.5. Now, what is this interquartile range? That is how big the box is in a box and whisker plot. This length right here is how big is our box and is known as the interquartile range. So we're going to have to find the median of the top half also. It lies halfway in between the fourth and fifth values. So let's take the average of those two values and we get 93. Our interquartile range is just the distance from here to here. Now that is not the number of data points, but the length of the box. So to determine that, we need to take quartile 3 minus quartile 1. 93 minus 76 gives us 17. Our interquartile range is 17. Let's plug that in where it needs to go. We've plugged, and now we need to just chug out where our lower fence is. 76 minus, what's 1.5 times 17? We get 25.5. 76 minus 25.5. We have a lower fence of 50.5. Now what that means is we have proven that any value less than 50.5 is an outlier and can be discarded or discarded and not considered in our data set. So bye-bye Holly's score, bring on the pepperoni, and we are ready to go. Now this can be applied to the upper fence too. The formula is very similar, but just a little bit different, but the same principle applies. Now remember, outliers, they will eat your results for lunch. Take them out before they take you out, if you can prove that they are outliers. Don't forget, I am real and I'm here for you. You can reach me at clake@idahova.org or at 208-847-0720. Send your questions my way and I'll do what I can to help you out.